Hi friends, let's look at problem 3723. Maximize sum of squares of digits. So here we want to return a string denoting a good integer n that achieves the maximum score. So here the maximum score will be the square sum, right? So here the score of a good integer n is the sum of the squares of the digits n, right? So given num and sum, a number is good if the number of digits in the number is exactly num, right? And the sum of the digits exactly sum. So if you look at the two examples, the first two examples, here, two digits have sum 3. So you have 3, 0, or 1, 2, and 2, 1. So here, 3, 0, the score is none, and 1, 2, or 2, 1 both have score 5. So we should return a none, right? We should return 3, 0. This is the string format, not the score itself. So in the second example, so we have 8, 9, or 9, 8. The thing we are going to return is this one, because the two numbers have the same score, but 98 is larger than 89. So in the third example, you have a single digit and the sum is 10. It's impossible, so you return empty, right? So here are the constraints as following. First, the total sum can be in this bound, and the number of digits, this is the number of digits, right? And this is the sum, right? So you notice that here is 10 to the power 5, here is 10 to the power 6. Because if you have a number which has this number of digits, then that is possible, it's like this, right? So with that said, so here it has some hint, but what we want to do actually is to do some simple analysis first, and then we write a solution which is just very routine. In other words, we just assign nines if possible. And then we also want to write a solution like when we write backtracking solutions. So here the thing is that let's use this example, right? So if we have two numbers, so for example, we have like using example 1, so the sum is 3, so we have 3, 0, or 1, 2, or 2, 1. 2, 1, these two are same. So which one should we choose? We should choose this one. The reason is that you can split the sum. Let's just split the sum into two. One is you put it at A, and then you put it at B. Or if A plus B is less than 9, you put A plus B in the beginning and then put a 0, right? So I would say the second one has the larger score, because the second one, the score is this A plus B squared, right? And the first one is A squared. The score will be A squared plus B squared. So obviously the first left side is greater than or equal to the right hand side when AB are non-negative. So this is the foundation that we can greatly assign nines if possible. But then our plan will be the following. First, write a quick solution based on our greedy strategy. The second is that write a solution like using like writing, right? Backtracking, right? So here we are not using backtracking, but we just write a solution and practice coding. So let's first write the first solution. So if you look at this example 3, so we can first do some exclusion. First, if the sum is greater than the total number of digits, that is num times. So here the sum, let's use S maybe, because this sum is not good in terms of sum is a function, built-in function in Python. So let's, if S is greater than n times none. So in this case, you cannot assign, even put all nines, you still cannot finish, right? So in this case, we just need to return an empty string. And otherwise, so we want to check how many nines we have. So def mode, so n divided by none, right? So our result will be like this. So first, let's prepare the result. So we can have q nines. Let's see. And then if r is non-zero, so we are going to make it a string. if R. Otherwise, so we just have an empty string. So then this will have a length, but we need to have those number of digits. Then otherwise, other places, if they exist, so we're going to place them as zeros. Therefore, we can return something like this. Return result plus 0 times n minus the length of this result, right? So that's actually exactly what we mentioned. Greatly assign lines if possible. Let's run it. So this is not right. Let's see what's the problem. So here, so we expect, so here, let's see, n minus length of result. So 9 times q plus string r if r otherwise. So here, let's see, what's the problem? Turn that mode. Yeah, so here we should have a 3. So let's print out this result. In the first example, so so here result plus 0 times n minus n. Oh, so here I got it wrong. So it should be s, right? So let's submit it again. So let's see. Yeah, it passes all the cases as I explained, and it's as it should. So now let's submit that. So it passes all the cases. So this is the one case, but it's too too straightforward because it's not like a coding problem, like some math. But now what we are going to do is to write a solution based on like we write backtracking. So I'm going to call this one version v1, right? So so here actually what we want to do is like this. So I'm going to initialize a result variable. So it's collect all the possible things like this, but not all the possible, but largest, right? So then I got a solution. So this is the variable that I'm going to append to this result. So what we do is this. So define a build function. This is the index, and this is the total, right? So later we are going to call this one with respect to this s. So this is the current position, right? So we need in total n positions, but the largest index will be n-1. So first we are going to check if I equals the total, right? It means assign all the integers. So what we are going to do is this. If total is 0, so means we finished that. So then what we can do is result append solution. So here I'm going to append a copy of that. So this is the one. All the other cases, so if total is not 0, so it means that we should have an empty one. So we just return, right? So then other case is if total is less than or equal to none, right? Then we can put the current position with a none. So solution append a total if it's less than or equal to total. So in this case, then we are going to build from next position, then 0. So otherwise, so total will be larger than none. So in this case, so we're going to do this. The current position, we're going to append a none. And then we're going to build from I plus 1, then the total minus none, right? So then what we are going to do is we are going to call this build function. So build, so from index 0, and the total is the sum s, right? And then what we let's print out the result to see if the result is empty or not. So for the first two, it should be not empty. So first one is 30, and second one is 98. So 98, and the third one is empty, right? So now let's prepare the return, right? So what we want to return is if not result. So we don't have a valid one, so we're going to return empty. Otherwise, we're going to return the John, right, of this. But we need to translate all those into a string format. So a string item, this item is a digit, right, for item in result 0. Then we can do a submit for this one. But let's first run it. Yeah, it passes all the cases. So now let's submit for generic case. Yeah, it passes all the cases, but it's not as fast as the first one because this is rather straightforward logically, right? But this is purely for fun or for coding. With that said, I guess that's it for the current video. Thank you for watching.